point of view. I'm your teaching assistant for chemistry, and I'm gonna teach you how to do stoichiochemistry calculations very easily, very fast. Okay? So in this reaction, we have um, sodium bicarbonate reacting with hydrochloric acid to make carbonic acid and sodium chloride. Okay? And so the first thing to do is list everything that you have reacting in the entire reaction. So we have sodium, hydrogen, carbon, oxygen, and chlorine reacting throughout this reaction, okay? The next step will be to list how many of those things you have for both sides. Uh, for the reactant side, for the reagent side, as well for the side, okay? All right, now that you listed how many of the things you have for both sides, then you're gonna start altering the reaction to balance it. So what I notice here is that I have one hydrogen on the reactant side and then two hydrogens on the product side. I need that to be balanced ASAP. So I would, these damn people need to mind their damn business. So I would just put a two here in the hydrochloric acid. Um, I'll put a 2 right in front of it and the coefficient, and that means I change the amount of hydrogens and also chlorines that I have on the reagent side. So right now I have 2 hydrogens and 2 chlorines on the reagent side, and so now my chlorines are not balanced. So I will go on the product side and fix that. So we'll just put a 2 on the coefficient for sodium chloride, and that will change also the amount of sodiums that I have, but also for the chlorines. So now everything is balanced except for the sodium, because now I have 2 sodiums on the product side, but only 1 on the reagent side. So I'm gonna go over on this side, and I'm gonna put a 2 just to see how it will look. Okay. Well, it looks good because it's gonna balance it sodium, but once you do that, you also change the amount of uh, things that you have on this uh, sodium bicarbonate. So you actually have 3. I counted. Um, we change the amount of hydrogens that we have for the reagent side. So we have 2 plus 2, that's 4 hydrogens actually. And then we have 2 carbons. Now we have 2 times 3, 6 oxygens on the reagent side, okay? And now it looks good, but I will need to balance my oxygens and my hydrogens as well as my carbons on the product side now. So I'm gonna do exactly that. Um, I know that my least common multiple for 4 is 2, so 2 times 2 are 4. So that's what I will put here in this coefficient for uh, carbonic acid, right? So 2 times 2, 4 half this. Now I change the amount of carbons that I have on the compound. I have 2 carbons, and then I also change the amount of oxygens that I have. So now I have 6 carbons, all right? And when I look at my table, it makes sense. Everything is balanced. This is the final balance equation. Um, all the coefficients summed up will equal to 8. Okay, and that's basically how you do it. Um, a quick explanation of why I strike everything and then I put the coefficient. So in my head, I'm multiplying by whatever coefficient that I'm gonna put here on the compound, and then I'm just putting the result here because this is my results. Like my when I count it all, this is what I write down. So say say that for the hydrochloric acid, um, I need a 2 here, okay? But so far you have 1 hydrogen and you have 1 chlorine. So in my head I do, okay, what multiple can I do to make this, I don't know, 2 here? So I'll multiply in my head. 1 times 2 So it will be 1 times 2 equals to 2. And then I cross this out, this calculation, because I already have something different in my actual chemical equation. So it will be 2. So that's what I will put on the coefficient of the compound. I will put my resulting, well, no, I will put my, what I multiplied it by. Okay? This, what you multiply by, will go on the coefficient, and this is just your result for what you counted. Okay? I hope that helps. All right.